In this podcast, I'm going to explain the method of dimensional analysis. This might be one of the most important concepts that you will use in clinical math in the class that you're in. It allows us to convert units. If we were talking about the number of miles in a marathon, and somebody asks you, well, how many feet is that? You can convert that to feet. You can convert that to inches. You can convert that to centimeters. We can take any unit and convert it. As long as there's a relationship between one unit and the next, we can convert it. So what's going to happen in our class, we're going to convert milligrams to micrograms, or we're going to convert liters to milliliters. We're going to convert milliliters per hour to drops per minute. So being able to convert between units is incredibly important. And that's what we're going to use. One way we're going to be able to do that is using dimensional analysis. And it's a problem-solving method that uses the fact any number or expression can be multiplied by 1 without changing its value. So I'm just going to illustrate that. First thing, and what you're going to really essentially be doing is multiplying things by 1. So let's take this number 5. Obviously, the property of multiplication, the identity property of multiplication, allows us to take any number, multiply it by 1, and it doesn't change the fact that it's still what we were left with. That's going to be important. We want to be able to multiply by something without changing its value. It would be nice for you to have $20 and just to double it and then have $40. That would be very nice. But that wouldn't be mathematically good for us, especially if you're calculating the amount of milligrams a patient is to receive. You don't want to just multiply that by 2 because that might have some damaging results. The point is we want to be able to multiply by things so it looks, and we're left with something that's left, or we're left with something that is the same as what we started with. So this is pretty obvious, right? Taking 5 and multiplying it by 1 and getting 5. That seems pretty silly. The thing is, we're not going to just be randomly multiplying by 1. We're going to be multiplying by things that, although they don't look exactly like the number 1, they are the same. It's the same thing as multiplying by the number 1. So another example, taking 5 and multiplying it by 2 over 2. This relationship here, 2 divided by 2, this expression, you look at it and say, well, that doesn't look like a 1. But if you were to simplify 2 divided by 2, this is the same thing as 1. So if we multiplied, let's first rewrite 5. I know a lot of people look at 5 by times 2 over 2. They look at that and say, I don't know how to do that. Just write 5 over 1. Up top, we're going to have 5 times 2. Down below, we're going to have 1 times 2. This is the same thing as 10 over 2, which is 5. So notice we multiply by something that, although it didn't look like 1, it was 1. And the last example here, let's just do 8 over 8. Up top, we'll have 40. Down below, we'll have 8. We're going to have 5. All right. I'm just going to quickly show you that it doesn't matter what you start with. It could be 5 or it could be 1/2. When we multiply things by, let's say 7 over 7, you get 7 over 14. And I'm not going to simplify that because if I were to simplify it, I would get exactly back to where we were. The point is 1/2 and 7/14 are the same when you simplify them. They are the same fraction because you just multiply by a factor of 1. So let's multiply by the square root of 2 over the square root of 2, just to mix some things up. Notice I'm multiplying again where the numerator and denominator are equivalent. That's the key. The numerator and denominator have to be equivalent. They have to be equal things, equal values. Up top, we'll have 1 times the square root of 2. Down below, we'll have 2 times the square root of 2. And I'm just going to leave it like that. We don't really need to worry about knowing how to simplify that. The point is we multiply by something and we're left with a value here that's equivalent to what we started with. This itself is not quite the dimensional analysis we'll be using. I just wanted to illustrate the fact that we can multiply by the number 1 or expressions that aren't exactly the number 1 but are equivalent to the expression of number 1. Let's use that now to convert between units. Let's convert this example. We know that there are 12 eggs in 1 dozen. We want to know how many eggs are in 5 dozen. Now, I know you may be looking at that and say, okay, take 5, multiply it by 12. And that's what we're going to do. And you may just know that because of experience, knowing working with these types of things that you multiply 5 times 12. But why do you do that? I want to look behind this easy example, and when we get to more complicated examples, allow us to come back to this if we need to. So the conversion that we're doing is we're going from, we're told we have 5 dozen, and we want to know how many eggs are in that 5 dozen. So we know 12 eggs is equal to 1 dozen. We want to know how many eggs are in 5 dozen. You could set this up using ratios and proportions, and we're going to get into that podcast later, but I want to use dimensional analysis. So what we do with dimensional analysis is we use these conversion factors. And these conversion factors are pretty much the same things. It's a ratio of 2 items that allows us to multiply by 1. They're equivalent to having a ratio of 1. So when we are multiplying in that last slide, multiplying by 1 or 2 over 2 or 7 over 7, we are multiplying by essentially a conversion factor, but we weren't converting between anything. What we're going to use here is the conversion factor. We know that 12 eggs equal 1 dozen. So when you are multiplying or you're working with things with dimensional analysis, write down what you're starting with. What do we want to start with? And think about what we're converting. We're starting with 5 dozen, and we want to do some math, and we want to know how many eggs this is. So we want to start with 5 dozen. You should write what you start with as a fraction. All right? So, and use units. The important thing is you're using units. So we're starting with 5 dozen. And how do I write 5 dozen as a fraction? Well, just write it over 1. That will help to eliminate confusion. Just write it over 1. Now we want to somehow multiply this by some factor of 1 and convert it. What we want to do is cancel out. All right, so let me write this out. We're going to multiply by some factor of 1, We want to multiply by some factor of 1, and we want to cancel out dozen. In order to cancel out this unit for dozen, we need to, since this is in the numerator, we must, in order to cancel out, have dozen down here in the denominator. That way, this dozen and this dozen will cancel. Just like if you had a 3 over 3, 3 divided by 3, they cancel to be 1, a ratio of 1. We need, if we're trying to cancel this, we have to, if it's in the numerator, have to have dozen, and our conversion factor has to have that unit in the denominator. And what do we want to go to? Well, we want to convert dozen to eggs. All right, this is the conversion factor. We need to convert dozen to eggs. Now, how do I fill in this spot? How many dozen equals how many eggs? This is the conversion factor that we're told. Well, 12 eggs is equivalent to 1 dozen. Notice this does not look like 1, but we are multiplying by a factor of 1 because these two, this numerator and this denominator, they are equivalent. This ratio is equivalent to 1. We're just using different units. So when we multiply this, when we multiply across, we're going to have 5 dozen times 12 eggs. And what's going to happen is this dozen is going to cancel with this dozen. And that's what I like to do. Even before I multiply, before I continue, I like to cross off what units are going to cancel. And then whatever doesn't cancel, I'm going to circle because that's the unit that I'm going to be left with. So up top, I'm going to have 5 times 12, and the unit's going to be eggs. And down below, I'm going to have 1 times 1, which is just 1, and there's no unit. This is the same as 60 eggs. This is dimensional analysis. I know when we saw this problem, you knew the answer right away. Just multiply by 12. The reason why we multiply by 12 is because of this conversion factor right here. When we're canceling dozen out, we know the conversion factor, 1 dozen is equal to 12 eggs. That's why we're multiplying by a factor of 1. so that the dozen cancels and we're left with eggs. Let's look at a more complicated example. In this example, we want to know how many miles are in 95,040 inches. So 95,040 inches is equivalent to how many miles? Now we want to use dimensional analysis, so we're going to be multiplying by conversion factors. If we had a conversion factor that went right from inches to miles, that would be great. And you could look it up and you could definitely find a conversion factor. But what we're told is 1 mile is equivalent to 5,280 feet, and 1 foot is equal to 12 inches. So using dimensional analysis, we write down what we're starting with, what we're given, and what we want to convert it into. So we want to start from 95,040 inches, and we want to convert that into miles. Do we have a conversion factor from inches to miles? You could look it up, yes, but from what we're given, no. We're just given this information. 1 mile is equal to 5,280 feet. 1 foot is equal to 12 inches. So we don't have an equivalency between inches and miles, but we do have an intermediate step. And what I mean by that is, if we can first convert inches into feet, then we can convert it into miles. So this step right here in the middle is our intermediate step. We're not able to convert from inches to miles directly, but we can first convert the inches into feet because we have a relationship between inches and feet, and then from feet into miles because we have that relationship. So let's do this. Let's first write down what we're given. We're given 95,040 inches. I'm going to write IN to abbreviate. And I want to write this as a fraction. Usually we start by writing this over 1. That would be a good thing to do, is just to write it over 1. And we want to convert into feet first, right? We can't go right to miles. So what we want to do is multiply by a conversion factor, and we want to convert inches, so that's going to go in our denominator, into feet. And this is what I like to do. I like to first think about inches in the numerator, so to cancel that out, inches is going to have to be in the denominator of my conversion factor, and I want to go from inches to feet. Now I want to fill in the relationship between inches and feet. Well, I know there are 12 inches in 1 foot. Now if we stopped here, if we stopped right here, what would happen is the inches would cancel, and I would be left with my answer in feet. But I don't want to do just stop at feet. I could multiply here and then in another problem, then change feet into miles. But the good thing about dimensional analysis is that it allows us to put in another step if we need to. Right? Because now if we were to stop, we would have feet. I want to cancel out feet. So I can actually multiply this by another conversion factor. And I want to cancel out feet. Feet is in the numerator. So to cancel out feet, I need to have feet down here in this conversion factor's denominator. And I want to go from feet to miles. And now, do I have a relationship between feet and miles? I do. Up here, 1 mile is equivalent to 5,280 feet. And now if I multiply, this unit of feet will cancel with this unit of feet. If I were to stop right now, let's see, what unit am I going to be left with? I circle that, miles. There are no other units available. The feet cancels with feet, inches cancel with inches. If I were to multiply this right now, I would be left with my answer in miles. And I'm starting with 95,040 inches, and by multiplying by these conversion factors, although they're changing the units, it's not changing the values because I'm using these conversion factors. They are equivalent to multiplying by 1 because the relationship between these conversion factors, numerator and denominators, are equivalent. So now if I were to multiply the numerator, right, I'm going to have 95,000 times 1 times 1, so that's 95,040. And my unit's going to be miles. So let's abbreviate that MI. Down below, I'm going to have 12 times 5,280, and there's going to be no unit down there. If I were to simplify this, I'm going to be left with 1.5 miles. And that's what I'm left with. I start with what I'm given, and using dimensional analysis is a two-step problem. I can't go directly from inches to miles, but what I can do is I can first go to feet in one step, and then multiply by another conversion factor between feet to miles. Let's look at one more example. Okay, here's another example. It's a little bit more complicated. We're going to convert 12 feet per second to miles per hour. This does get a little bit more complicated because we're dealing with more than one unit at a time. But here are our conversion factors. They're not always going to be given, so you're going to have to memorize a lot of the conversion factors in this particular class, especially between different units of mass and volume and length as well, and other different things. So you're going to have to be able to know some of these conversion factors. So we want to convert feet per second to miles per hour. What I'm going to do is start out by writing the unit that I'm given. So I'm given 12 feet, and I'm not going to just write feet per second over 1. What I'm going to do is write this as a rate, 12 feet per 1 second. This is the value that I'm starting with. 12 feet is equivalent to 1 second. I'm going to travel 12 feet in 1 second. And I'm not just converting between feet and canceling that out, but now I want to cancel feet and I want to cancel seconds. So the first thing I want to do is let's get rid of this feet. What do I want to convert that to? Well, I'm starting with feet. I need to end with miles per hour. That's the same thing as at the very end of my answer here. I'm going to want this to be, I'm going to want to have miles up top, and I'm going to want hour down in the denominator. So I need to cancel feet first. So since this is in the numerator here, I'm going to need feet down here, and I want to convert that to miles. And I know the conversion factor. This is 5,280, as we saw in the last example. Up above, we have 1 mile. If I were to stop right now, what would happen? Well, the feet would cancel. If I were to stop right now and multiply across and multiply down below, my units that I would be left with would be miles per second. Right? If I were to stop right now, because the feet would cancel, I still have second in the denominator, but my feet would be converted to miles. So I am done with half of it, right? I have miles in the numerator, so I'm going to circle that. I am done with that. That's what I got. I'm not quite done because I don't want seconds in the denominator. I want miles per hour, so I need to convert seconds to hours. Now the tricky part about this is in order to cancel out this unit that's in the denominator, I'm going to multiply by another conversion factor, but I'm not going to be putting the unit of seconds in the denominator here. I'm not going to go seconds to minutes or seconds to hours, whatever it may be. But since I want to cancel out seconds, and that's in the denominator, I would have to write that up here. Now, do we have a conversion factor going right from seconds to hours? Some people know how many seconds are an hour, but if you don't know that off the top of your head, let's first convert this to minutes and then go from minutes to hours. That's what I'm going to do. So I'm going to first, in my intermediate step, go from seconds to minutes. You might be saying, well, how can you multiply this? It's not next to 12 feet over 1 second. How can I put that over on this side? The reason is because multiplication is commutative, right? I could right now just multiply this and my answer would be in miles per second. And then take this answer and now multiply it by this. And then I can take this whole answer and multiply it by another conversion factor. You can do that piece by piece and have lots of little problems in one. But it's a lot easier to know that since multiplication is commutative, you know this is going to be a string of multiplication. Just write this whole thing out and then multiply all in one step. So that's why we can write it here, and it's still affecting the solution that we would get if we multiplied this out. Okay, so that little rant is over. I'm going to convert between seconds and minutes. I know there are 60 seconds in 1 minute. If I were to stop right now, seconds cancel. I would have miles per minute, but I don't want miles per minute. I want to cancel out minutes. So since minutes is in the denominator, I need to cancel that out. That means it's going to have to be in the numerator. And I want to convert from minutes to hours. And I know there are 60 minutes in 1 hour. Minutes cancel. And I have miles. And I have hour. So right now, if I were to stop and multiply my numerators, I would have miles up top. And multiply all my denominators, I would have hour. Exactly what I want. So now I'm going to multiply all the numerators. 12 times 1. So I'm just going to write this as 12 times 60 times 60. Up top, that's going to be miles, right? Because that's what was circled. And down below, I'll have 1 times 5,280 times 1, which is just 5,280. And my unit down below is hours. So up top, let's see. Up top, if we were to multiply 12 times 60 times 60, we're going to get 43,200, and this is miles, all over 5,280 hours. We want to simplify this, right? We want to know the exact speed. So when we divide 43,200 by 5,280, we're going to get about, this is approximately, it's not quite correct, but it's about 8.182. It's around there to the thousandths place. And this is miles per hour. MPH, you could also write this as 8.182 miles per 1 hour. So that MPH is the same thing as miles per hour. This is converting rates, and you're going to have to be able to do this. There are other ways and other strategies that we can take to convert units, but this is dimensional analysis.